Hello, I wanted to walk you through quick examples of probability. For example, if we look at the first question here, an experiment has 3 steps with 3 outcomes possible for the first step, 2 outcomes for the second step, and 4 outcomes possible for the third step. How many experimental outcomes exist for the entire experiment? Well, this is pretty straightforward. So we have it laid out nicely here. So for step 1, we're simply entering how many possible outcomes do we have. So we have 3 outcomes for the first step, we have 2 outcomes for the second step, and we have 4 possible outcomes for the third step. To find out the total possible outcomes, we simply do this, equals step 1 times step 2 times step 3, and enter. We have 24 possible outcomes. Number 2. How many ways can 3 items, or K, be selected from a group of 6 items of N? Use A, B, C, D, E, and F to identify the items in each of the combinations. So if we look at the calculation here, we have N to exclamation. The exclamation simply means the factorial. So this is the population factorial. We divide that by the k factorial of n minus k factorial. So if we want to represent this, it looks like 6 factorial divided by 3 factorial times 6 minus 3 factorial. So it'd be 3 factorial times 3 factorial. Okay? It can be represented by 6 times 5 times 4 times 3 times 2 because we have 6, a factorial of 6. So 6, 5, 4, 3, 2. And typically would also have 1, but when we multiply anything by 1, it remains constant, so we take the 1 out of here. And then if we look at 3 factorial times the 6 minus 3 factorial, we're simply saying 3 times 2 times 3 times 2. Again, this would be represented as 3 times 2 times 1, 3 times 2 times 1. But again, we take the 1's out because multiplying anything by 1 just gives the same value. So for simplicity, we just take those out. So 5 times 4, okay, so we use Excel, we simply say equals 5 times 4 and enter. Okay, it's 20. If we look at 6 factorial, what this really can say is, just to kind of put it in a meaningful way here, I'm going to go ahead and click over here and I'm going to do this. It's really saying factorial 6, which is 6, 5, 4, 3, 2, 1, divided by 3 factorial times 6 minus 3 factorial. So this is just saying 3 times 2 times 1 times 3 times 2 times 1. Okay, so 3 factorial of 3 times factorial of 3. Okay, it's really important that we understand how we calculate this because we can use Excel to get to this number quite easily, but you need to understand what this means when we say 6 factorial. Okay, so if I was to do 6 times 5 times 4 times 2 times 1, it equals 720. All these multiplied here would be 36. We divide 720 by 36, we get 20. There's actually an easier way of doing this. We can actually use Excel functions. So we can say equals FACTs for factorial. We're going to open the parentheses, and this is going to say what's the number. What we want to do, factorial 6. Okay, because that's this number right here, factorial 6. We hit enter. There's 720. Okay, again, if you multiply this, this becomes 720. So we now know how we get to that 720 mark. Now this right here is saying, okay, you want to take the factorial of 3 times the factorial of 6 minus 3, or factorial of 3, and hit enter. And now we have 36. Again, we can validate this because we know how to do that. 3 times 2 times 1 times 3 times 2 times 1. We do an equals 720. Divided by 36, and now we have 20 different combinations. Are you seeing a pattern here? We have 5 times 4 equals 20. Those are the combinations. We have using the factorial range, which equals 20, And then we have this other thing using a combination. It's not looking at the combination function in Excel. It simply takes the combination of saying 6, and there's 3 different options. So what we do here is we do an equals, combin, comes right up here. It says returns the number of combinations for a given number of items. Okay, so now we take our number, which is 6, and we want to take it by 3. Okay, because there's 3 steps. Okay, close the parentheses, and now we have 20. So all 3 different ways we can come up with the same answer, just different ways of getting there. If we look at all the possible outcomes for tossing a coin 3 times, the first toss could be heads, tails, and then we can actually branch off from there. The heads, the next toss could be a heads, tails, and then the toss after that could be heads, tails, heads, tails, heads, tails, heads, tails. Okay, so we have 8 different combinations. The different combinations of tossing a coin 3 times would look like this. All right, so we're tossing a coin 3 times. We toss a coin 3 times. We have the possibility could be a heads, heads, heads. It could be heads, heads, tail, head, tail, heads, and so on. And we can represent that in this diagram above here. Okay, so what's the total number of possibility of each one of these occurring? Well, there's 8 different combinations that can happen. Okay, so it's simply 1/8. Okay, it could be 1 and 8. We have 8 different combinations here. And so anytime we flip 3 coins, we can reach any one of these combinations at equal probability. Okay, now looking at the next scenario here, we say an experiment with 3 outcomes has been repeated 50 times, and the results were E1 is 20 times, E2 is 13 times, and E3 is 17 times. We represent this here, E1, 20, 13, and 17. Assign the probabilities of each outcome. We need to be able to determine how many values we have here. So all we're going to do here is click over here and say the auto sum. It's going to automatically do that, and we have 50 here. So now what we're going to say here is equals 20 divided by D52. I'm going to go ahead and lock my cells here because I'm going to copy this down. So I have 40% chance of E1 occurring, 26% of E2, and then 34% of E3. Now, if we did this correctly, we're calculating the entire population, so this really should equal to 1. If we got all the percentages are captured, it should be 1. Again, I'll select the auto sum here. It highlights the rows there, hit enter, and we have 1. Okay, looking at number 7 here. We have a decision maker subjectively assign the following probabilities to the 4 outcomes of an experiment. They have 0.1, 0.15, 0.4, and 0.2. If I go ahead and sum all this up, I'm going to say equals this plus this plus this plus this. Enter. I have 0.85. So obviously I have not captured all the following probabilities, because if we did, we would equal 1. So are the probabilities valid? We know it's not 1, so we know it's false. However, we can actually use a calculation to determine this. We can say equals, we're going to put an if statement in here because this is going to be an if condition. We're looking at whether a statement is true or false. So we're going to say if, open parentheses, we're going to pick our value here of N55. That's our logical test. So if N55 equals 1, we know it's a true, or it's a valid probabilities. Okay. So if N55 equals 1, that's my test. If the value is true, in other words, if it equals 1, I'm going to put yes. If I put a comma here, you'll notice it gets to the next value and puts it in bold and says, okay, well, what happens if it's false? I'm going to say no. So if N55 equals 1, it's yes. Otherwise, populate it with N. And there we go. We have an N because it's not 1. We want to be able to explain this. Explanation is pretty simple here. The sum of the probability is not 1, therefore the model is not valid. That's our explanation. Okay. Looking at number 10 here, we look at venture capital. What is the probability that a company will be chosen from California? Well, looking at our values here, we have the state of California. There's 1,434 venture disbursements there, 390 in Massachusetts, 217 in New York, and 112 in Colorado. If I sum this value here, I have 2,153. Well, if I look at all states, there's 2,374 ventures across all states. It looks like they only captured 4 states here, so we know we're missing some. Okay, so what is the probability that a company will be chosen from California? That calculation is relatively simple. We just want to take the equal sign. We want to take the number of venture disbursements in California and divide it not by this number here, which is a total of 4 states, but we want to capture all the states. Okay, so simply the number of California divided by the total number of venture capital or venture disbursements across the nation, and hit enter. So now we have the probability that a company will be chosen from California is 60%. What is the probability that a company will not be from one of the states mentioned below? What we will know is that we have a difference between 2374 and 2153. So we're saying there has to be a difference. So if I say equals 2374 minus 2153, I'm saying there's 221 venture disbursements that's not accountable. Okay, so that 221 is the number we're looking for. So what's the probability of a company being in that 221? So all I'm going to do here is I'm going to wrap that in parentheses because we want to make sure our calculation is correct. And we're going to divide that by the total number of the states. So now we're going to say there's a 9% chance that the company will not be from one of the 4 states mentioned. What is the probability that a firm will not be in the early stages of development? So we have early stages of development is 22%, and we have an expansion stage of 55%. Well, looking at these two, that doesn't equal 100%. It's only 77%. So what I want to do is, this calculation is fairly simple. I'm going to say equals 1 because it's 100% minus 22%. Because 22% are in the early stage, so that means what's left is 78%. So 78% probability that a firm will not be in the early stages of development. I want to go ahead and kind of demonstrate these numbers a little bit more carefully because so we can actually validate these numbers. If I look at the percentage of population for each one of these, so if I look at California, Massachusetts, New York, and Colorado, and then all, we want to know what each one as percentage is. So if I say equals California divided by the total population, or capital N, I'll go ahead and lock this because I'm going to copy this down. Okay, so I have 60% from California, 16% from Massachusetts, 9% from New York, and 4% from Colorado. Well, if I was to sum this up, we'll notice that, again, if I was to sum this up, it would simply be equals sum of this. Well, now we see that it's only 90% of the population. Okay, because this is the percentage of the total population. So again, remember we had this probability the company will not be one of the states above. So if I do this, I'm going to include this number in here. And now look at that. Now I have 100%. So we can validate our numbers. Now we can validate that, yes, sure enough, 9.3% really is all other states other than the 4, and that the 60% is in California. So we validated our numbers. So if the question was, what's the percentage that would be in Massachusetts, I could say 16%. 9% in New York, 4% in Colorado. And of course the 9.3% in all other. That's what I wanted to cover on this particular demonstration.